Hello everyone. Today I'll be presenting my project report, which covers several machine learning assignments and applied exercises. I'll walk you through an enterprise ML strategy first, then several data reprocessing and modeling projects, and then a set of model comparisons, each with the practical findings and recommended next steps. So let's begin. First part of the project involves designing an enterprise machine learning strategy for a firm. For this exercise, I selected Starbucks Corporation, which we all know is a global leader in coffee retail. Starbucks operates over 38,000 stores worldwide and competes in a highly digital and fast moving retail environment. Competitors such as McDonald's and Dunkin's are already applying ML to improve operations and customer experience. To preserve and grow its market leadership, Starbucks must adopt a company wide ML strategy. Now that we have set the context, we need to explain why a company of Starbucks size and digital reach needs ML and what specific business problems it can solve. The retail food industry is characterized by rapid shifts in customer demand, supply chain variability, and intense digital engagement. Starbucks already has a major strategic asset, that is its mobile app and loyalty program with over 30 million active members. This data gives Starbucks a unique opportunity. So, why machine learning? Machine learning can be applied, first of all, to personalize recommendations in the app, improve store level demand forecasting, reduce waste, optimize inventory, support dynamic menu and price tuning, automate workforce scheduling, and increase operating efficiency across the organization. Each of these improvements has both top line, that is better customer engagement, and bottom line, reduce costs and waste impacts. Given these opportunities, the next essential question is governance. How to organize ML development, deployment, and ethics across the company. The vision is to transform Starbucks into a fully data driven retailer where ML augments decision and operations. To do this responsibility and at scale, I recommend two governance elements. First, create an AI steering committee made up of leaders in technology, operations, finance, and marketing to set strategy, priorities, and KPIs. Second, implement responsible AI policies that address data privacy, fairness, and model auditing. This governance ensures the right balance of speed, control, and ethics as we scale ML. Now, with governance and vision in place, we need the right technology ecosystem. And here is that ecosystem looks alike. To support enterprise ML, Starbucks should implement a layered technology stack. First, cloud infrastructure like AWS or Azure for scalable compute and storage. Second, a unified data lakehouse like Snowflake to integrate app, inventory, logistics. Third, ML frameworks like scikit-learn for research and production models. Then, MLflow for model versioning, deployment, and monitoring. Key data inputs include app usage and loyalty records, vendor supply chain feeds, and workforce scheduling logs. Properly integrated, these sources support a wide range of ML applications. Now, let's look at the prioritized use cases, like what to build first and what to defer. I recommend a staged use case portfolio. Short term includes to implement personalized app recommendations, store level demand forecasting to reduce stockouts and waste, and automatic scheduling. Then, long term, we can expand to ML enabled supply chain routing, localized menu optimization, and computer vision for queue detection and equipment monitoring. These projects require broader integration, but deliver deeper operational transformation. Next, solutions require people as much as technology. So here's the human capital plan. To implement and sustain ML programs, Starbucks must invest in talent, hire data scientists, ML engineers, and data engineers, and invest in company wide data literacy training. Embedding ML practitioners inside business units rather than having a completely centralized team. This helps improve adoption. Then incentives and change management will be required so store managers and operation teams adopt ML driven suggestions. Next, the strategic plan is executed in three phases. So here's the implementation roadmap. Phase 1, build foundational cloud and lakehouse infrastructure and launch two pilot projects. For example, forecasting and basic personalization. Phase 2, productionize pilots, deploy ML operations, and roll ML into supply chain and staffing. Phase 3, scale advanced applications, include computer vision and sustainability models, and embed ML into global operations. This approach delivers incremental benefits while creating a platform for future innovation. Now, the most important part, that finally, how to measure success. Key performance indicators include increased mobile app engagement, higher loyalty utilization, reduced store level waste, improved labor utilization and scheduling accuracy, better forecast accuracy, and improved operational margins. These KPIs show that ML is driving both customer and operational value. In short, Starbucks is well positioned to scale ML because of its digital footprint and data assets. With the right governance, technology, and talent, ML can substantially improve personalization, efficiency, and sustainability. A company wide ML strategy is not optional, but it's essential to maintain competitiveness in this data driven market. So that includes part 1. Now, moving on to next part. Now, we'll describe complete pre-processing workflow for Austin Animal Shelter dataset. Now, I'll explain how each step matters before data modeling. The project's immediate goal was to clean the data and prepare a modeling ready dataset to predict an animal's outcome. For example, whether an animal is adopted, returned to owner, transferred, or otherwise. This dataset, this Austin Animal Shelter, it has over 95,000 records spanning from October 2013 to April 2020. It has about 10 features like the age of animal, date and time when it was intake into the shelter, and so on, and one target outcome type variable, which is our target. For this pre-processing, all these tasks pre-processing, they were performed in Python within a Jupyter notebook. And I used pandas for data cleaning and manipulation, and NumPy was used for numeric operations. This environment allows reproducible, auditable pre-processing. Now, to begin with pre-processing, the first step was to load the data and inspect the data types, missing values, and the distribution. I checked for unusual tokens like 0 or like question mark, and then inconsistent formatting, which informed subsequent cleaning rules. First important step include removing irrelevant columns. I removed the attributes that risk leakage or provided no predictive signal at intake. Those four attributes were: first, animal ID. This acts only as identifier, so no value. Second, day, time, and third, month of year. These both reflect outcome type, outcome time, and not intake, so they are not required. And last, date of birth. This is redundant once age is computed, so I removed all these irrelevant columns. Next step of pre-processing was to convert age into months. The age upon outcome field came as text like 2 years or 7 months. I implemented a robust conversion function that extracted the numeric portion, converted years or weeks or days into months. Values like 3 plus or invalid tokens, they were coursed to NaN, that is not a number, and then handled in imputation. The result is a consistent numeric column, that is age upon outcome in months. For categorical columns like sex upon outcome or outcome type, breed, color, all the missing values, they were replaced with unknown. For age in months, only 4 values remained missing after conversion. These were imputed with the median age of the animal. Finally, any residual NaNs were filled with the median to ensure a modeling ready dataset. So, after all the cleaning and validation, that is removing the redundant attributes, converting the text age to numeric column having the age in months, handling the missing values. Finally, the cleaned dataset was saved as animal sheltered clean.csv. So that completes the second part of the project, which was cleaning and pre-processing these dataset so that it can be finally used for ML model.